Have you ever wondered what quantum physics really reveals about the universe? Some discoveries are so startling that even scientists hesitate to discuss them. Imagine a universe where the void is not truly empty but a vibrant field full of potentialities, where particles can arise from nothing and disappear in the blink of an eye. Quantum theory is both fascinating and, at times, terrifying. One of its most impressive revelations is the possibility of creating something from nothing. This might sound like magic, but it's a real prediction of quantum mechanics. The Schwinger effect, proposed by physicist Julian Schwinger in 1951, suggests that extremely strong electric fields can create pairs of particles and antiparticles from the vacuum. Recently, after 70 years, this prediction was verified in the laboratory, showing that the vacuum is not as empty as it seems. The quantum vacuum is a constant bubbling of virtual particles that appear and disappear quickly. When sufficiently strong electric fields are applied, these virtual particles can become real, creating matter literally from nothing. This challenges our traditional understanding of the conservation of mass and energy, presenting a reality where the universe can generate particles from the seemingly empty vacuum. This discovery not only validates theoretical predictions but also opens doors to new forms of manipulating matter and energy. The Schwinger effect is just one of many startling revelations of quantum theory. It shows us that the vacuum, which we once considered a simple nothingness, is actually a dynamic field full of potentialities. This concept challenges our notions of reality and suggests that the universe is much stranger than we imagined. Modern discoveries in physics show us that the universe is much more dynamic and complex than we thought. Instead of being composed of static entities like atoms and molecules, the universe is formed by quantum fields that permeate all space. These fields are the true foundations of reality, manifesting latent energies under certain conditions. Quantum fields are like an invisible sea that extends throughout the universe. Even in the deepest vacuum, these fields are present, ready to manifest into real particles under the right conditions. For example, electromagnetic fields, Higgs fields, and other fundamental fields play crucial roles in the formation and interaction of matter. The dynamics of these fields are what give rise to everything we see in the universe, from stars to subatomic particles. Understanding the universe as a tapestry of dynamic fields opens new possibilities for scientific exploration. Manipulating these fields may allow us to create new forms of matter and energy, revealing a cosmos where creation and transformation are constant. The nature of the universe, as revealed by quantum theory, is an unending dance of energy and information. Even in the absolute emptiness of space, quantum fields continue to operate, and their constant fluctuations give rise to virtual particles that appear and disappear incessantly. This incessant activity is a reminder that the universe is intrinsically dynamic. The Casimir effect, demonstrated experimentally in 1996, illustrates this reality by showing that two metal plates close together in a vacuum are attracted due to quantum field fluctuations, creating an observable force. These virtual particles are brief manifestations of the latent energies of quantum fields. They can spontaneously arise, collide, and annihilate within fractions of a second. However, when these particles encounter the right conditions, such as a sufficiently strong electric field, they can become real particles. This constant transformation challenges our perception of emptiness and shows that what we consider nothing is actually full of invisible activities fundamental to the existence of the universe. The interaction between quantum fields and particles is fundamental to the formation of matter that makes up the universe. Quantum fields, such as electromagnetic and Higgs fields, interact in complex ways to form the particles we know, like electrons, quarks, and neutrinos. These particles, in turn, are the building blocks of all matter. The Schwinger effect phenomenon was theoretically described by Julian Schwinger in 1951 but took decades to be experimentally verified. Recently, experiments with graphene confirmed the creation of pairs of electrons and holes, a kind of condensed matter, validating the theoretical predictions and demonstrating that the creation of matter from the vacuum is possible. These experiments show that, under the right conditions, the quantum vacuum can be a source of particle creation. When a sufficiently strong electric field is applied, it can provide the necessary energy for the virtual particles in the vacuum to become real. In the case of graphene, this incredible carbon substance in the form of a thin sheet, applying an electric field led to the creation of pairs of electrons and holes, providing concrete proof that the Schwinger effect is real. The creation of matter from the vacuum challenges our traditional notions of the conservation of energy and matter, opening new frontiers for scientific research. The creation of particles and the formation of matter in the universe depend on the types of quantum fields present. These fields include the electromagnetic, strong, weak, and Higgs fields, each playing a crucial role in the interactions that shape reality. The electromagnetic field is responsible for forces between charged particles, while the strong field keeps quarks together within protons and neutrons. The weak field is vital for processes of radioactive decay, and the Higgs field gives mass to particles. These fields not only coexist but interact in complex ways to form the structure of the universe. For example, the Higgs field, a relatively recent discovery, is fundamental to understanding why particles have mass. Without this interaction, elementary particles would remain massless, and the universe would be a very different place. These interactions are like a symphony, where each field plays its part to create the harmony of matter and energy that we observe. Understanding these interactions is essential for modern physics and any future advancements. These phenomena not only challenge our understanding of reality but also lead us to new discoveries about the nature of the cosmos. Quantum theories and experiments continue to challenge our understanding of reality, revealing a universe much stranger and more dynamic than we imagined. These scientific advances lead us to question what we know about the nature of matter and energy and how these invisible forces shape everything around us. These discoveries not only validate decades-old theories but also inspire us to explore more deeply the fundamental properties of the universe. Each new revelation brings us closer to a more complete understanding of the nature of reality. The exploration of the quantum universe is an ongoing endeavor, with scientists constantly testing the limits of what we know. The creation of matter from the vacuum, the complex interactions of quantum fields, and the incessant fluctuations in the vacuum are just the beginning. As we continue to investigate, we are led to consider even more fantastic possibilities and revelations that could forever change our view of the cosmos. By exploring the revelations of quantum theory, we realize that the universe is much more mysterious and complex than we imagined. These discoveries challenge our deepest beliefs and open new possibilities for understanding reality. Thinking that we are only scratching the surface of what quantum physics can teach us is both terrifying and exciting. Each new discovery brings us closer to a complete understanding of the cosmos, revealing a dynamic universe full of surprises. These revelations not only expand our scientific knowledge but also inspire a profound admiration for the intricate workings of nature. If you want to continue exploring these mysteries and learn more about the incredible revelations of quantum physics, subscribe to the channel and activate notifications. Let's continue unraveling the secrets of the universe and diving ever deeper into the enigmas it presents. See you in the next video.